Hello, everyone. Welcome to this webinar on why businesses need data science from Inside AI/ML. My name is Pranjal Biani, and I work as an AI scientist for a material informatics startup based out of Singapore. We are building the next generation AI tools to support the life of material scientists across the globe. Whenever we are interacting with a lot of our customers, clients, people that I interact with on a daily basis, which are at a very senior position in large companies, a fundamental question that troubles all these small, medium, and large scale businesses is, how do we organize data? What kind of data do you as a data scientist need that can help us derive insights and take decisions based on data? So it's a very fundamental level that we are going to talk at today. We are going to make sure that we understand step by step all the processes that go into building the database that will eventually fuel a data-based decision-making strategy for the entire company, right? Let's assume you are a part of a big company. We are going to talk about every step, every stage, every level and layer at which data needs to be collected, classified, organized, and stored in such a way that this data can be eventually feeding to an AI model, to a data science or a data analysis module. It can be fueling a statistical module, which will be accessible across the company to all the stakeholders, right? So let's quickly discuss about the topics that we are going to cover today. We are going to start with categorizing and classifying data, all the steps involved in this process. Then we are going to talk about the good, better, and the best data organization strategies. We'll also learn about data classification, data tabulation, graphical presentation of data, as well as diagrammatic representation of data. So it's going to be a very interesting session covering all the important topics. Okay. The first most interesting step is for someone to strategize, plan, and ideate the entire process of data collection. Let me take you through a very interesting example where I'm going to consider the marketing domain. Okay. In the meantime, if anyone has any questions, I'm going to keep the YouTube live feed with me, right? So that if anyone has any questions, I can directly answer them. So yeah, Pushpanjali, Nisha, Rakshit, all of you, if you have any questions, just share it on the chat, on the live chat, and I will surely pick them up and answer them. Let's take the example of the marketing domain. Suppose you are a large company that does marketing of variety of its products, and these marketing campaigns help you to generate more revenue by increasing your sales. Now, you got to hear of this data science buzz, right? Machine learning, AI, how it is changing the world, why database decision making is the next thing that every company should adapt to, right? And the top level stakeholders immediately start thinking, what is the step one? How do I start collecting, storing, aggregating data at each and every step, right? So that after I collect this data for 2 or 3 years, then I can hire a data scientist or I can hire another company that can do my entire data analytics for me. Okay, let's take the example of marketing. So a big company can market in 2 types of places. First is offline and online. They can have hoardings on highways, or they can have Google ads, Facebook ads, YouTube ads, and different online advertisement channels. Now, once you consider a particular offline or an online channel, there are multiple channels that comprise of this platform. So channels could be Facebook, Google, YouTube, then Snapchat, Pinterest, all these individual channels. In these individual channels that you have a lot of platforms as well. For example, there will be a digital specific platform. There will be a video specific platform, right? Each platform can be divided into different types. And then these types can further be divided into impression creating platform, search platform, AdWords, keyword matching, etc., etc., etc. And finally, for all of these individual platforms, how much are you spending in each one of them must be recorded, right? You also need to decide on the frequency of data collection. Are you going to store the spends you are doing on every single aspect? You should do it on every day basis, weekly basis, monthly basis, yearly basis. And the golden rule answer to that is always have the minimum frequency. If you may ask the reason is simple. From the smallest frequency, you can always go to the largest frequency. But if you have the largest frequency, you cannot divide it into smaller frequencies. For example, you collect data at a weekly level. You can never give me data at a daily level. But if you collect data at a daily level, you will always be able to aggregate it at a weekly level and share the data with anyone across your company, with other third-party vendors or partners, etc., etc. Any questions so far, guys? Yeah. If there are any questions, please do note them down. Now, once you have known the individual layers or segregations at which data is generated, suppose you are spending $500 on day 1, which is a Friday, and you're spending it on Facebook videos, and you are targeting an audience of the age 20 to 40. You know, Facebook has collected your birthday, so they know your age, they know your gender, they also know a lot of your preferences. So based on that, I can go to Facebook and ask them to market, or in the marketing terms, target a particular set or character of customers who are more likely to buy my product. So if I'm selling makeup products, I'm going to definitely go to women in between a particular age group. Right? If I am selling, let's say, protein, right? Simple gym protein, then I'm going to target, youngsters between a particular age group. So that way, Facebook helps you in marketing better, targeting the right customers. And you also have different layers between your choices, right? So you can choose gender, you can choose age group, you can choose geography. Do you want to market it in India, Asia, America, wherever you want to market it? And then it increases, Facebook, let's say there are 5 types of advertisements possible on Facebook. Then from Facebook, it becomes digital marketing, right? So digital marketing is one. Then digital marketing is a part of online marketing. And then it's your total marketing. So the data collected at every layer, it's important because a stakeholder would know what is my total spend in marketing and what is my revenue. That's number 1 metric. Second is, they will also know how much you are spending in each aspect, in each source, and how much you are generating from each source. Okay. So the next concept, after you understand the different layers and points of data source, is you are going to understand what are the different impact levers. Okay. What are the different data points important for you to make sense of your data? For example, if you are working for, let's say, a fooding company, right? A company that makes food, or let's say a restaurant, which is like a fast food restaurant, you know that your sales between Monday to Friday is not very high compared to your sales on Saturday and Sunday. Is that correct, everyone? Does that make sense? A restaurant knows that its sale is largely on Saturday and Sunday compared to the weekdays. So the day of the week is an important input metric or data that you must collect, because that is going to directly affect the output, which is why we are saying we should find the impact levers which will have a potential correlation, right? It will have a potential correlation, and it will make sure that you adopt the right practices and the right data sets are collected. So we need to find the impact levers to get the right correlation at each stage. Then we are going to divide the entire process into segments, categories, and unique identifiers. What do we mean by that? Suppose you are spending some amount in a particular geography. So that geography is an important data point, right? So there will be an additional column added in your data frame, which will say geography or area or region. And then you will mark that this is Asia, this is Europe, this is let's say United Kingdom, this is US, this is China, this is Africa, etc., etc. So you are supposed to divide your data into different segments internally. And then also you are supposed to divide your data into multiple segments externally. What do we mean by that? So you should have your spends data separate. You should have your revenue data separate. You should have your employee data separate. You should have your company expenses data separate, right? All of these individual data will help you because you can later cluster them into each other, right? You can merge them using the right strategies of intersection. But it will also help you to individually analyze. Plus, it also helps you to access and manage your data correctly. For example, if you want to give a third-party company which is working with you access to your data, you will not give them access to any kind of confidential data, right? So you need to also categorize your data into different parts so that you can identify them uniquely. The second question is, if you ever have a doubt on should I have this data or should I not have this data? If you're ever having any kind of doubt on whether you should or should not keep a data set, the golden rule is always add that data, right? Because what is the compromise? Nisha, impact levers means things that impact something. For example, my success in life can be impacted by the hard work I do, the sacrifices I make, the books I read, the skills I gain. So these are all impact levers of my life. So the impact lever of a company would be transportation, infrastructure, leadership, management, employee retention, satisfaction, etc., etc. Right? Anything that can impact the output is what is an impact lever. Now, the golden rule is have all the data. So why am I saying to keep all the data? Because today, the ability to store data is very cheap. So data storage systems are very cheaply available online. You can store terabytes and petabytes of data at a very minimal cost. Earlier, this was not possible. So people were selectively adding only the most important data points. But now, since storing data is very cheap, you should always add all the data, right? The second aspect is you should also add documentation to all the data points you add, because you might understand the complexity of your business. You might know that this particular table actually links to this particular table with this primary key, and this particular column is important only when this particular table comes into the picture, and only when these two tables come together is when I can link these two tables. You can set these equations and maps in your head because you are the designer of the database. But someone else in the future, when they use it, they will definitely need a document where you have noted down each and every step carefully. Does that make sense, everyone? Yes, no? Yeah. Okay. The next step is to standardize the data. Okay. A very classical problem that you are going to get in data is that people save data in multiple formats. Let me quickly clear all the drawings and open up a new notebook. Right? Suppose you want to save the name of states in India, right? Very simple example. If you ask 10 to 20 different individuals to write the name of a state, you will see that there are significant differences. For example, let's consider the state Himachal Pradesh. So someone will write Himachal Pradesh. Okay. Someone will write Himachal Pradesh. Someone will write Himachal Pradesh. Someone will write Himachal. Someone will write Himachal Pradesh like this. Someone will write Himachal Pradesh like this. Are you getting the problem with data being entered manually by humans? The problem is that this data cannot be used together because they are not the same. So we cannot create linkages in the data. Suppose I want to know how many people have added their data in my data list from Himachal Pradesh. Now I can either count the number of occurrences of Himachal Pradesh like this, or this, or this, or anything, right? I would never know that there are other Himachal Pradeshes added in my data manually, which have either wrong spelling or title case, smaller case, lower case, upper case, etc., etc., right? So that is why it's very important for us to understand that we need to standardize our data really well. What do I mean by standardizing the data? You should already know the possible categories that you can select from. Do not give the user any kind of ability to write that data by themselves. If they choose or if they select from a drop down, then you can always ensure that your data is standardized. It will not have multiple versions of the same information. Okay. Once you've done that, it's also very important to define the relationships between the data points. So the relationships are basically of different kinds. Let's look at them in practice. Right? So there are three different types of relationships. In data. Okay. The first one is one-to-one mapping. Right? Then is one-to-many mapping. And the final is many-to-many mapping. And these can actually be also changed a little bit, because you can have many-to-one relationship also, right? So if you reverse the one-to-many, it can also be called many-to-one mapping. So let's say we are going to say it's 4 different types of relationships. Otherwise, ideally, there are only 3, right? What is a one-to-one mapping? You and your Aadhaar card number. This is a 1:1 map. So if I search any Indian by their Aadhaar card number, there will only be one individual for that Aadhaar card number. So there is a 1:1 mapping. Second is 1:many mapping. Does any idea, any example come in mind for one-to-many? One-to-many mapping. You and your bank accounts, right? So one person can have multiple bank accounts. So one-to-many mapping, right? Now, many-to-one mapping. Let's say you go to a school, right? So you and your school, right? Students and their school name. So many students go to one school. So many-to-one mapping. And finally, many-to-many mapping, teachers to school, right? Let's say teachers to schools might not be that relevant. Yeah. So there are a lot of professors that teach in multiple colleges. So professors to colleges, right? So one college has multiple professors. One professor can actually be teaching in multiple colleges as well, right? So you need to define the relationships like this. For example, one customer can buy multiple products. Okay. One product can be bought by multiple customers, right? So what is the relation between a customer and a product? The relationship is one-to-many. What is the relationship between a product and a customer? One-to-many again. Is this clear to everyone? Right? So you need to define these relationships, right? So one product can have multiple sizes, right? That's also a relationship. So these relationships must be clearly defined before proceeding. And finally, you should have objective workflows. Now, this is specific largely to technological industries, right? Or industries where the sequence of action matters, right? What is a workflow? Suppose I try to explain to you how, let's say, how a pizza is made, right? On a Saturday, we're going to talk about how pizza is made, right? So you have step one, right? You get dough, right? Right? Or let's go below that. Step one is get the raw ingredient, right? It can be wheat, it can be, or maize or rice or any kind of raw ingredient that you use, right? Some people like to have the normal pizza, some like to have thin crust, wheat crust, all of that. So the raw ingredient, then, you make the dough. Then let's say you add toppings. I'm going to just simplify the process. And then let's say you are going to add seasoning, right? The idea here is the taste of the pizza. The taste of the pizza depends on each and every step of the process. Does everyone understand that? Yes or no? The taste of the final made pizza depends on the all the individual steps, because I move from step 1 to step 2, then to step 3, then to step 4, right? How my customer purchases a product, that is not dependent on anything else. Customer likes a product, they buy it. But what is the taste of my pizza, the ultimate result, that is definitely going to be impacted by a lot of other factors. So we need to have the proper data flow. So the ingredient table should match the dough table. The dough table should match the add toppings table. The toppings table should match the seasoning table, and so on and so forth. So you need to have a flow of how can you start from the beginning and go till the end, right? That was categorizing and classifying data. The next is good data organization strategies. These are largely to protect you and your organization from a major loss, financial, as well as informational, as well as, let's say, proprietary data or intellectual property. So the first thing is you should always keep multiple database copies, because you never know when databases might get corrupted. The cloud platforms might not work. Some hardware failure occurs. Google Cloud is down. AWS is down. They had to restart everything. The storage is completely lost, or any mishap. Suppose you stored your data in a Google Cloud platform where the Google Cloud server is located in some earthquake prone area, and the earthquake happened. What happens after that? All your data is lost. So you have to create multiple data copies with backup. Then a lot of individual tools that you are going to use might need different formats of data. So you should also have your data in different formats, right? Different formats, CSV, JSON, XML, Excel, all of these different factors should also be considered. Okay. For SQL applications, you should have the understanding of each and every column. So when you save your data, suppose you are storing a date column, right? Do you want to save just the year? Do you want to save the month? Do you want to save the date, day, hour, minute, seconds? What is it that you want to save, right? When you want to store a customer ID, does the customer ID have to be unique? Or can the customer ID have different links? For example, a family can have an ID, so that entire family gets benefit of that customer. What are the foreign keys? What are the primary keys? What are the tables linked to this table? How are they linked? What columns exist? And then you have something called as an ER diagram, which is a very, very important concept. Okay. For database management, there is a concept called ER diagram. The ER diagram is a very essential document that tells you how your databases are connected, right? So you see this particular chart. Here, you can actually derive all the relationships between your tables and data. So this particular sign represents many. This represents one. Again, this represents many, right? So you can see this. Apparel size has 3 data points. What is the size ID, size code, and sort order? Many apparel sizes belong to different products. So one product, which has a product name, product ID, and other data about it, can have only one size, right? A single piece of cloth can have only one size, right? You cannot have a t-shirt which is small and medium. It will either be small or medium. That is why you have a 1:many relationships, right? So one product can also have multiple sizes, but individual product will only have one size, right? Then one product can actually belong to multiple categories, right? For example, a t-shirt can belong to a fashion category. It can also belong to a t-shirts category. It can also belong to a branded clothes category, right? So one-to-many relationship. Product colors, obviously, one product can be launched in many colors, as well as one color can be three products can have the same color, right? So all of this link, individual tables, their links, their individual details, they comprise of the ER diagram. This ER diagram actually helps you and your organization and your business to understand how your data is placed inside the database. Okay, primary key will be unique. That is correct, Nisha. Now, standardized sizes and dimensions for image-based data. Suppose, let's say when we upload any kind of government form, why does it say upload less than 1 MB? Right? Otherwise, you might be clicking an HD picture, which is not required for the government validation, right? And when you put those high-sized images, the government has to pay to save your image on their system or server, and that comes at a cost. That is why you standardize for sizes, dimensions, etc. Then you should also have a collaborative user access management system. For example, the company's CEO should have access to all the data sets, right? But the associate of the company should not have access to all the data sets. I mean, the new joining associate should not know the employee salary table. He should not know how he is being paid compared to his other peers. I mean, morally he should, but the company wants to hide that kind of information from all the employees, right? For example, if you are a new joinee or you are an intern, you are not given access to the company's revenues, books, etc., etc. But any leader or stakeholder of the company, let's say the investor in the company, has full access to all the books of the company, right? So you have to have user access management. Then there should be a flow and accountability. Accountability means this table belongs to this team. So if there is any error in this particular table, this particular team is responsible. Okay. There should be standard enforcement and logs. For example, one particular table cannot access another table. That is an enforcement, right? Logs, basically every action on your platform should be logged. That data can be recorded. Because log is a structured form of data, you can extract data from them, right? A log could basically look something like this. Log data, right? It will look like a very organized and structured data, right? You can see area global, name Q4, description flow tank 4, atom actual value, date, time, etc. Right? Then you can see this is a single log data. You can actually collect this data and then convert it into a database as well. Yeah. Then standard enforcement in logs is clear. Descriptive, diagnostic, predictive, and prescriptive analysis tools. This is very important. Once you have the data, you should also have a strategy to have descriptive analysis. What is descriptive analysis? The history, right? We are describing what has already happened. What is diagnostic? We are trying to find out loopholes or problems. Let's say the sales immediately went down by 10%. That can be a real fall of the business, or that could be, let's say, a data issue, right? For example, credit card companies and databases encounter this problem a lot of time. So suppose you made a transaction on your credit card and then you eventually returned the order or canceled the transaction. That amount gets reversed in your credit card. And what you eventually see in your credit card is basically let's say a reverse transaction or a negative transaction. So if you're looking at a certain period where the negative transaction was not added to your bill, then you will see that you are paying insanely high amount. And if you're seeing a period of time where the actual transaction was not involved, but the negative transaction is involved, you will see that you are having to pay negative bill, right? So those kind of data issues can actually mislead you. So you need diagnostic analysis. Then there is predictive, which is predicting the future. And finally, it's prescriptive. By looking at the predictions, understanding the history, the current and the future, what steps you should take as a business. For example, in the marketing example that we saw, we can actually decide how much to invest in what platform. What platform is getting me the highest sales? So that is the prescriptive recommendation. Okay. Great. Any questions so far? Anyone? I hope Nisha, flow and accountability were clear. Okay. Now, data classification. Data should actually be classified also by the source it is coming from. For example, is this data generated by your own platform? Are you the owner of this data set generated by me? Or is this the data derived from sources? For example, there is an online website from which you have derived the data. Let's take an example, temperature. If you want to see if your customers are spending more on a sunny day or a rainy day or a cold winter day, how would you know? You would have to get the data. You will have to derive the data from online resources where you can get temperatures of each and every day. Then you can map that temperature of each day with your actual data, your client daily data. And there you can basically define the sales of each day and then come up with an analysis. If summer days directly lead to a lot of sales of water or cold drinks or soft drinks, etc. Then there are third-party data sets. What are third-party data sets? These are data sets that I have basically received from other parties, but these are not data sets where I have given some amount. Suppose I am a big manufacturer. Now I have a lot of distribution centers where the distribution centers are owned by let's say, wholesalers, right? I make a lot of rice. I'm a farmer. I make rice. Now, once I produce rice, I send it to my distributors or wholesalers who eventually sell it to people, right? So when I get data from these people, my wholesalers, my distribution points, this is my third party data because I am the first party. The second party is my consumer. The third party is the person facilitating the transaction. And finally, it's the purchase data. What is the purchase data? This is data which I am buying from external sources to add on to my data set or my analysis. Suppose I buy, you might have heard, Facebook is selling data, Google is selling data, Microsoft is selling data, all these big companies, Snapchat, Pinterest, WhatsApp, these are selling data. So who are they selling to? They are selling it to companies which are big enough to utilize that data. And then these companies can sell you products that you are more likely to love, right? For example, if someone buys a lot of books, so they will be shown advertisements of new books, right? Someone likes to buy a lot of technical gadgets, so they will be shown advertisements of gadgets more, right? So the data that I can get from these sources can actually help me to have a better marketing campaign, to target customers better, etc., etc. Right? Then comes the data type based classification. So your image data set can be completely separate. Let's say you are a manufacturing company. You want to know that can you use the images of your final product to determine or predict the quality of the product. Suppose I give you the picture of 50 different kinds of rices. Okay, rice produced in different parts of India. I give you the quality of that rice. I can directly give you the quality with respect to price. So higher the price, better the quality of the rice, which is a good enough assumption to make. And now I ask you to predict the price of a new picture, a new image of rice. What this is basically a image detection or image classification problem where you are using images to perform or predict values, right? These images or texts, right? These images, texts, audio, for example, where can audio be used? When you get calls from customer care, right? Do you remember these guys telling you that this call will be recorded for training and quality purpose, right? Why is that? Because they want to know the good and bad effects of the audio, the way you are talking to the customer, the time you are talking to the customer for, the fluency of the language. Was it a positive conversation or a negative conversation? Was the voice very angry, aggressive, or was the voice very calm, relaxed? All of these can be derived from these different sources of data, right? Then data can be classified into types as well, which is numerical and categorical. So image, text, and audio is the first level segmentation of data type. Then you have numerical or categorical. So is it a number or is it a category, right? Then is it a Boolean, for example, yes, no, true, false kind of data? Then if it's a number, is it a discrete number or a continuous number? For example, if I ask you to rate out of 10, so you have a discrete space, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But if I ask you to predict the price of a product, then that can be like 100.5, 216.89. So that process is that prediction of price is a continuous value. Then nominal and ordinal data. What is nominal data? Nominal data is the categorical data that does not have order. For example, red, green, blue, they have no order. But ordinal data is also categorical, but it has an order. So good, better, best, right? So numerical data can be classified into different numerical data, Boolean, discrete, continuous. Categorical data can be divided into multiple parts, nominal and ordinal, right? And then these data sets can be available in different formats. For example, images can be available in JPEG, JPG, text data can be available in, let's say, .txt, right? .pdf, etc. Tabular data can be available in Excel format, .csv, etc. Right? And finally, your data should also be classified with respect to security. So a lot of companies genuinely forget that how important data security is as a concern, right? Suppose your competitors get to know about your data, or they are able to purchase your data from third parties. So they have a competitive advantage over you, right? Suppose you are working on some secret project where you are developing a COVID vaccine, right? One company in the world developed COVID vaccine, I mean, from India and, Asia Pacific region. Now imagine if that particular formula would have been leaked to all the medicine manufacturing companies in the world. Then the company that invented the COVID vaccine would no longer be able to treat COVID. I mean, no longer be able to make profit from their, multiple sales that came from the COVID vaccine. So confidential access, internal access is only for your team members. You don't want to have it access outside your team. Public access is access to the world. Restricted access is, it is restricted to certain users only. So it can be only team leaders can access this, or only managers can access it, or only CEOs can access this data, right? All of those individual complications can come, right? Graphical representation, right? First of all, I'd like to quickly take any questions from the group. Jugal, Nisha, anyone has any questions, let me know. Coming to graphical presentation of data, this is where, the statement, a picture speaks 1,000 words is very, very essential. Why? Because data can be represented with respect to numbers, or in fact, data can be just shared with anyone. But the insights, the analysis, the learning from the data happens only and only when the data is presented in a format that communicates some information or insight, right? So suppose I want to show you the prosperity of different states of India. If I give you numbers, West Bengal X, Maharashtra Y, Karnataka Z, if I give you 30 different numbers, right, that might not be a very, very relevant way to represent the information that I'm trying to communicate. But if I give you a bar chart, you can directly see which is the most prosperous state in India, the one with the highest bar, right? Which is the least prosperous, one with the lowest bar, right? What is the average prosperity? There will be a single line. Every state above it is a good state. Every state below it might not be working well, right? So the graphical representation really gives you a very good communication of what the data is trying to communicate with you, right? It also has relevance by stakeholder relationships. So let's say the owner of the company, right, or the stock owners of the company or the stakeholders, they might not be interested in every nitty-gritty details about everything that happens in the company. They might only be invested in total spend and total earning, right? I spent 100, I got the total revenue of 120, so I made a profit of 20. So my profit margin is 20%. That's all they might want to know, right? They might want to know this by each part of the company. So finance part of the company, marketing part of the company, healthcare, X, Y, Z, A, B, C, all the different parts, right? We also need to have the ability to have dynamic tools with options for multiple views. Suppose I want to look at the progress specifically in West Bengal, right? Then I want to look at the progress specifically in Maharashtra. So when I want to look at these two comparisons, I shouldn't have to go and ask someone else to give me that analysis, because that creates a lot of resistance and it also wastes a lot of time. But if there is a dynamic tool where I can select the state name and that chart gets generated, select another state, the chart gets generated. That's what users and stakeholders want, right? Confidential data points should obviously be encrypted, right? Something might be confidential that you do not want to share with everyone. Let's say you have developed a material, which is like a top class material. You don't want to share the name of the material or the chemical of that material, right? Then charting types, what is the kind of chart you should show? Distribution, comparison, relationships, one-dimensional, two-dimensional, three-dimensional. Okay, all of these individual chart types communicate, right? Suppose I want to show chart types for analysis, right? Not stock market analysis, chart types. Let's say I'm going to look at chart types in Python, right? You can see choose right chart type, right? Let's look at this image. Such an interesting image. When you want to observe the distribution of some data, you are going to use histograms, line histograms, scatter chart, 3D area chart, etc. Right? So distribution of a single variable, choose any of these two. Distribution of multiple variables, choose any of these two. Composition. So if you have a static composition, use pie chart. If you have a dynamic contribution, you can use stacked area chart, right? Or you can use stacked column chart. Few periods, many periods, right? Components of components, accumulation or subtraction. Then if you want to observe relationships, scatter plot or bubble chart, two-dimensional, three-dimensional, right? If you want to compare things, you can compare with bar charts, you can compare with line charts, right? Column area chart, bar chart, table or embedded table charts. So you should know what kind of chart are you really looking for the particular analysis or communication you want to make, right? Then parallel highlights for anomalies based on accepted ranges. Suppose you are getting some data set from the internet where the age of a human being is written as 550, right? It's wrong because it's not humanly possible for someone to have an age of 550, right? It is an outlier in the data, right? Even if someone's age is 120, which you might think is possible, or someone is alive who is 120 years of age, but that will still not be good for your analysis because it is going to be an outlier and it might communicate wrong information or bias your presentation, right? For all of these graphical presentations, we do not want someone to manually program it. We want someone to automate it and write scripts that can automate the entire process and generate charts. And these automation and scripts should be available 24/7. So someone sitting in the US should be able to look at the charts at night time in India, right? So there shouldn't be a dependency of some engineer or some individual, and only then the charts can be shown. Okay, so that should also be resolved. And finally, dashboarding for the KPIs. So at any point of time, if any stakeholder wants to know what is the progress of the company with respect to a particular KPI, KPI is short for key performance index, they should have the ability to know that my sales are going up, number of active users is going higher, or my revenue is going down, my profit margin is going down. So these key indexes, performance indexes, should always be available to the user, right? Last final slide, diagrammatic presentation of data. So whenever you have these data sets, you should give your user the complete ability to play with the data as well, right? So with SQL or any kind of analysis tools, you should be able to filter data, right? Just like we can filter data in Excel, right? You should be able to sort the data. Sorting should be provided at a column level or multiple column levels also. You should be able to merge, concatenate different data sets together. Every company should honestly focus on a very important end-to-end analysis and reporting tool, either using Power BI, Tableau, Excel, etc., etc. But that end-to-end analysis and reporting tool will really drive a lot of business value because you will have every decision taken in a very informed manner. No decision is taken without validating the, let's say, possible outcomes of that decision with respect to the data. There should be trackers and notifiers for updates. Suppose something went wrong in one of your systems, right? Something went wrong in one of your databases. So there should be trackers to notify you that something went wrong. Please fix it immediately. Then the classic analysis tools, pivot tables, group by, frequency distribution, etc. And you should also have customized charts specific to your domain. So let's say the finance domain wants to look at certain charts particularly, which the healthcare domain might not want to look at, right? So those are individual charts which should have numbers, let's say geographic analysis, distributions, thresholds that are specific to a particular domain. And we should make sure that those charts and tools are also available to our users, right? So I hope all the individual aspects of how businesses should think about collecting data, aggregating data, organizing data, storing data. What should they store? How should they store it? How should they categorize it? What things they should make sure before taking any decision? All of those individual concepts and ideas that I have discussed with all of you in this webinar are absolutely clear to all of you. If there are any questions, I would just like to open the forum for Q&A, right? Nisha, what is 2D and 3D chart, right? So 2D versus 3D chart. Okay, let's look at it. When you can analyze two variables at a time, that is a two-dimensional chart. So the normal X and Y that we see, it is a two-dimensional chart. You can analyze how length varies with respect to height or how height varies with respect to length. 3D shapes is where we can actually observe the variation of three variables at a time. I know how length varies with respect to changes in height and width. Similarly, I know how height varies with respect to changes in width and length, right? So two-dimensional is basically like a sheet of paper. Three-dimension is like sheets of paper, or let's say a rectangle or a square, right? Two-dimensional surfaces, this is a circle, this is a square, this is a rectangle. Then you have a cylinder or a sphere for a circle. Then for square, you have a cube. For rectangle, you have a cuboid, right? If you can analyze multiple dimensions, more than two, they become a 3D chart. So humanly, there is only 3D chart possible. There is no 4D possible. Okay. But 2D and 3D charts are used in a lot of ways. Okay. So that we can analyze multiple variables together. Any other questions? Anyone? In terms of data. Okay. So yeah, let me quickly show you. Right. So if you have three columns, right? If you have three columns, that will indicate three-dimensional data. If you have two columns, that will indicate two-dimensional data. Does that make sense? I mean, 2D scatter versus 3D scatter chart. If you look at this. So this is a three-dimensional scatter plot. Here, with respect to the data points, you also get to see the sizes of the data, right? Suppose I want to see how does age and education vary with respect to salary. right? Let me take you through a note, right? Let's observe this. Suppose this is my x-axis. Let's say this is age, right? And let's say this is education, right? Now I have 3 columns in my data. I have 3 columns in my data frame. Okay. One is my age column, right? The other is, let's say, my education column. How many years have I been educated? And the final is my salary column or my earning column, right? There are 3 columns. So this particular goes here, the age. This one goes here, the education. And this is what I want to observe. Okay. This is what I want to observe. What I will do is I can observe education and age, how they vary with respect to each other by a line chart. Suppose a common trend would be with increasing age, the education also increases. After a certain age, education becomes constant because you are no longer getting educated after a certain age, right? When you are like 0 years of age, there is no education, right? And then, 1 year of age, 2 year of age, 3 year of age, you have, and after like, let's say 25 or 30, you have a constant education, right? Most of the people have similar education. But now if I want to look at salary, I cannot do that here. Okay. But if I convert this entire chart, okay, this entire chart, if I convert it into a scatter plot, okay, I plot points like this. They are eventually going up, right? With more age, there is more education. But I am also going to have shapes of these points. A larger circle represents a larger salary. So the more you get educated, the more salary you are going to make. Does that make sense? So the trend of education being almost constant is the same here. After a certain age, education has become constant, but I am also able to represent the salary or the earnings potential of individuals. So this is where I have converted a 2-dimensional data into a 3-dimensional data. Is that clear? Yes, no? I hope it is. Yeah. Great. So yes, guys, that was it for today's webinar. I hope all of you had a great time. You can definitely connect with the Inside AI ML team and look for some amazing courses where teachers like me teach Python, data science, machine learning, AI, deep learning, and all the interesting and cool topics that are very interesting to learn, as well as are very highly paid jobs in today's market. Okay. I hope you had a great time in the webinar. I had an amazing time.